Hello there and welcome to this course on Tidyverse Fundamentals. My name is Valentine and I'll be your instructor. In this course, we are going to take this structure. We'll get started learning about the goals of the course itself. After that, we'll get to talk about important concepts pertaining to Tidyverse fundamentals. So getting to talk about what those fundamentals entail, as well as also talk about what Tidyverse is and why we would want to learn about it. After that, we will go into a practice session where we'll get to practice how to work with Tidyverse fundamental concepts. So this will be with regards to packages belonging to the Tidyverse ecosystem. And then towards the very end, we'll talk about the next steps. So let's get started. By the end of today, we are expected to have achieved these learning outcomes. So we should be able to recall and explain the core components of the Tidyverse packages. So Tidyverse is a collection of packages that we can use in R. We should also be able to apply Tidyverse functions for data manipulation, visualization, and analysis. The functions, the packages that we are going to be using from Tidyverse will come with functions that we can use to perform various types of analysis. We should also be able to analyze data using Tidyverse packages to derive meaningful insights. We'll also be able to evaluate the efficiency and effectiveness of Tidyverse workflows compared to traditional data manipulation methods. Something to note is that during the course of this workshop, if you feel like we are too fast in terms of going through concepts, or if you feel like maybe we lost you somewhere, or maybe you would want to, so if you feel generally, if we are too fast, you can feel free to pause the video and maybe research a bit more, or that is if the concept is too complex. Or you could also decide to simply just rewind and follow through the mentioned concepts. Feel free also to ask questions in the comment section too. So getting started, what is generally Tidyverse? You know, we might have questions about what Tidyverse entails, but generally Tidyverse is a collection of packages that we can use for various use cases. We can use Tidyverse for various use cases. For example, we could use Tidyverse for data manipulation. We could use Tidyverse, which are packages for various types of concepts. So I'm just going to pause a bit and visit the Tidyverse packages website, where we can be able to generally get an idea of what those Tidyverse packages are. And these are the mentioned packages. There's ggplot, dplyr, tidyr, readr, parr, table, stringr, forcats. These packages work together, and the idea is that in that process you're able to you perform the analysis that you would want. Maybe you would want to perform or create some sort of data report. Then you can be able to use these packages to be able to perform not only just data visualization. So one of the packages that you could use for that is ggplot. But before you perform data visualization, you can perform data manipulation, so wrangling data. You can use dplyr, or you could also use tidyr to clean data. Dplyr, you can use it to create summary tables. You can use readr to import data from different data sets or data sources, such as the TSV, CSV, FWF. There are quite a large number of them. Parr allows you to be able to work with functions as well as vectors. Table is a way of representing data sets using what are called tables, which is a data structure in now that's provided by Table, the package itself. You can manipulate package strings, that's textual data using string R. So generally, Tidyverse itself is a collection of packages that allow us to perform just various types of analysis. So And that analysis can start off from just basic doing descriptive analysis to predictive analytics to even just creating visualizations that we can use maybe in PowerPoint presentations or in PDF documents or in Word documents, etc. The idea behind having all these packages belong to one particular ecosystem is because is due to the fact that they tend to use the same approach when it comes to how you work with them. So there is some sort of consistent grammar and data structure that you would use, which generally makes them easier to read in terms of that code, as well as generally easier to learn and use together. So you can be able to perform some particular tasks, such as being able to filter data from a table, which would be a data structure provided by one of the packages, which is tables. So Tidyverse, I think I've just covered a bit of what it is. In terms of packages, these are just the different packages that you would find within the ecosystem. Tidyverse packages, there's dplyr, tidyr, ggplot, readr, par, tibble, stringr, forcats, and lubridate for just working with dates as well as times in R. So if you want to perform time series analysis, then that library comes in very handy. Why would you want to use? I've already talked a bit about a few reasons why you'd want to use Tidyverse packages to perform analysis if you have some knowledge in R, or if you're getting started with R. But the idea is that you would have a consistent and syntax grammar. So how those packages work is that they when you write code from one package to the other, they sort of use the same sort of approach, and you can be able to write complex code using those multiple tools, as opposed to if you're to use one tool probably to read maybe just code, and afterwards you may not be sure what and you, if you decide maybe to use another maybe data set somewhere else, it might be a bit difficult. But generally, one thing about Tidyverse packages that they share consistent syntax and grammar. They're also readable and easier to understand, and they're able to help you to perform complex data manipulations easily. They work together. That way, if you are able to import data using one package, you're able to also wrangle data with the other package that's within that ecosystem, as well as visualization. And there's a large community of vibrant, community of developers and users that primarily use R in their analysis. So that means if you wanted to also familiarize yourself with a language or way of writing R that's standard, then learning about R will be important. All right, so moving on, limitations. Of course, there are limitations with learning all these packages. Sometimes these packages, if you have rare occasions, maybe you have large data sets, extremely large data sets, and you'd want to perform some certain tasks, then these packages may not necessarily be the best option. So you might default to the basic inbuilt R functions provided by R, the programming language, to work with those large data sets. In terms of also steep learning curve, there are many packages. It's not just one package. So there are quite a large number of packages, and it means that you would have to learn all those packages all together. We'll go through about 9, but again, there are also other indirect packages that you can also get to work with. But the core packages are the ones that are listed on their website that you can be able to use and be able to use in your project. So there's ggplot, 3, 4, 5, 6, 7, 8. There's another one, lubricate, Rubridate, that you would use as well. That's also, we are going to also get to learn about it, but it's not there are 8 technically core packages, but we're going to learn of another one as well that you can also use together with these packages to just ensure that you're able to work well. So like you can see, for importation, Reader can get data from all these data sources. Rango, you can Rango data, as well as perform data manipulation tasks with other libraries. So the other packages. So let's get started with our analysis at this particular point, as after just talking about just a few limitations. Oh yeah, one more limitation is that, before I forget, if you have legacy code that you've written in R, the packages, the Tidyverse packages, does not work with, say, legacy code. So if you have a project that you've implemented with the basic R functions, then it means that you would need either to upgrade the older code or to write now new code in still legacy code. So that's also some limitation. So it doesn't really work together with, it's not compatible with the legacy code. So yeah, so at this particular point, we're going to move on into our practice work. So visit the description in the description in this video. So click on that resources link, and it should take you to a page where you can download the sample resource for this workshop. Once you click on the sample resource, you will get to some page that looks like this, where you need to download the file. Once you have downloaded it onto your computer, then you can be able to upload it to the platform that we're going to be using, posit.cloud. So visit posit.cloud on your computer. So if you visit posit.cloud, you should be in a position to let me just share that, posit.cloud. You should be in a position to sign up for a free account. So go to posit.cloud, sign up for a free account. But if you have RStudio installed locally, you can still follow through our work. But again, this is just an easier way for those who just quickly want to get started. So once you get there, once you've signed in, you will get to a dashboard that looks like this. So you will go to the far right, new project, new RStudio project, create a project. You can rename it at the very top. You can call it Tidyverse Fundamentals. Press enter, and that's going to be the project that we're going to be using. So do that. You can pause the video, ensure that you've signed in, and once you've signed in, we should be good to go. It should take a few seconds or so. All right, so once it has loaded, we need to upload our sample resource. If you're an Afterwork member, you'll get 2 other files. There'll be a practice file with lots of challenges that you can be able to practice with, and also a solution notebook that you can use to verify your solutions for the challenges. So if you are looking towards learning R and are here, don't just to go with the sample. Think about going straight into practice, and you'll have access to all the resources that we have at Afterwork. So let's get started. Upload, click on the upload button here and upload the file that we're going to be using, sample workbook, which I have uploaded. It will upload here. That's the first one. I'll upload the others as well for use if you want maybe solution, you can do the same thing, and also you can also do the same thing with the practice one. All right, so once you have done that, they should appear here, bottom. Then you can click on the sample. We'll work with the sample for now. And an editor will show up here. It will ask you to import or install Tidyverse and our Markdown packages. Click on install. And under background jobs tab, you should have the installation happening. For those who are new, this is just the RStudio environment. It's a software that allows us to be able to write or to create our projects. The focus for today will generally be to go through all the different packages provided by Tidyverse, and we are going to be generally getting a feel of what it takes to just go through a package, what each package has in store for us. I will also not emphasize majorly on extensive work on each package. At the moment, it's just to get a feel. So if you feel like maybe you want extra resources for practicing how to work with some of these packages, you can visit our YouTube channel or our Afterwork channel and go through the our program tutorials or courses that we have. You can start with R fundamentals, then data wrangling with R. We also have data visualization, machine learning with R, etc. That will give you more practice. This is just a quick overview of what R can do for you. So we've got now our installations happened. So our packages have been installed. The next thing that we need to do, click on visual. Again, you can pause the video if you feel like we're too fast, and you can minimize this. So, and wait for it to load. And you can also just adjust how big you want your editor to show up. So you just say, if you see a pop-up, just say use visual mode, and we can get started. This is a sample workbook. It's not practice, it's sample. It was technically a sample, but we removed the challenges for the sample workbook. We only have a few. So to start off, we normally first of all would import Tidyverse packages. There are 8 of them. We can just import them as such. And we set it to quiet. We use the install.packages function and specify the Tidyverse function, the Tidyverse package that we want to. We specify that we want to install Tidyverse packages by simply using a string here, and also setting quiet to equal to true. Run that. Then we can import Tidyverse packages. So once we have gotten them, we install them, which they're here. Technically, they usually 8 listed on the website, but lube read 8 is also the 9th one. So once we have done that, now we'll start off with just working with the different packages. So starting off, read R is the package that we normally use to read files from different data sources. So how we can be able to do that? Say we have a CSV file or maybe another flat file, we can use reader for that. So how do we do that? Because we've already imported Tidyverse, we will just use the read CSV function from read R and specify then our URL. It could be a file name or a URL for where the data source is. If you have other data sources, you can consult the documentation for read R by just going to Tidyverse packages and then visiting the read R page, and you can click on even packages and then click on the respective one, read R, then go through just the information. You'll see the different functions that you can use, as well as parameters that you can also consider using. Yeah, so that's a quick overview of that. So let's import this data set and store it in sales data variable and display the results. So this is what we have. All right, so this particular point, I'm going to give you the opportunity to practice working with read R behind the scenes. So yeah, pause the video and then work on the challenge. All right, so yeah, this is the challenge. Once you've done, then we can continue. If you're an Afterwork member, click on the solution workbook and verify the solution. With also read R, we can be able to export our data. So once we have cleaned our data, we can decide to export it maybe in a CSV format. So how we do that, assuming that this is the data set that we had, we loaded it, and then we performed some operation. We filtered. So this is the data set. Then we filtered data. This is some operation that we did. Still, this is using one of, the Tidyverse packages. We're using actually 2. here we use the write CSV function from readr, and we specify that we want to export this data set, this one that we have is the final, and then we specify the URL, not the name of the file, .csv. And when we save that, the CSV will be saved on the bottom right. So if I expand my screen a bit, so you'll find the CSV somewhere here. So if I run this, it will appear here, which is here, and I can click on it and then go to more and choose export, and I can be able to export that. So let me even just push this up so I can go to more, then export once I have selected it. Let me minimize that. Do somewhere in between here. Okay, let me just minimize that. I can also minimize it completely, but yeah, so that's okay. All right, work on the challenge that you have here. Then once you're done, we can continue. This deep layer, the deep layer package, I used to call it the deep layer. It's not deep layer, deep layer. So we can perform data manipulation tasks with a deep layer package. There are quite a large number of data manipulation tasks that we can perform. But for now, we're going to learn how to extract, extract specific columns, or to select columns that we would want to work with during our analysis. Maybe we don't want to work with all the columns in our data set because they're not relevant to analysis. So let's load this data set and preview how it looks. So, well, and check how it looks. This is our data set. To be able to select the columns, we can use the select function. So first of all, we create a new variable called selected columns, where we will store the selected columns. Then we use the left assignment operator to store the store the outcome of the selection operation. So we specify first the data set that we want to select data from. Then we use a pipe operator. This usually chains operations that we want to perform on the data set or the data frame. So that we have. And once we have done that, we then chain now this operation, which is basically a function that selects products, price, and quantity, product, price, and quantity, and we can then work with that. So the outcome of that selection is stored in selected columns, and then we display it. All right, we've seen how to select data using dplyr, so work on the challenge. Pause the video. All right, filtering rows. We can also use the dplyr to filter for rows. The idea is just to get a subset of our data that's specifically for our analysis. And yeah, so initially we will first load our data set, the data set that we want to work with. Then once we have done that, we will still follow the same format as we did earlier for just creating a variable and then storing the results of what comes on the right-hand side. So this is just, by the way, this is just like this, but it's only for readability. I put it like that. So I consider the sales data data frame, and I apply this operation that we have here, filter. I want to filter for quantity is greater than 2, and I'll get the outcome of this operation and store it in filter data, and I display it here. So yeah, if you have multiple conditions, you can always use double. You can always use brackets, and then use a brackets, and then use ampersand, or you can use or, and also, so if you're to use ampersand to say and, you can also have another condition here. Maybe quantity is greater than 2 but less than 5. You can also do the same thing. So for example, this is what we have as an outcome. If you want an or, you can also use a pipe operator to just do that. But if you have multiple words in your columns, it's good practice, column names, it's good practice to use the delimiter characters to enclose the column names. All right, pause the video if you're an Afterwork member and work on the challenge. Moving on, mutating columns. Sometimes you might want to create a new column. So for example, in this data set that we have here, which I have loaded, we might want to create total price as a new column. We don't have total price here. still we are using dplyr. So what we will do is we will apply a mutate function to the data frame that we have loaded, and inside the mutate function we will specify the new column name and then equate it to what is on the right, which will be our operation, depending on your needs. So total price, it will be total price, which is what we have here, times 1 minus discount. So the records for the values for discount column, divide by 100, and then the outcome of what's on the right here will be the values that we get on the right hand side will be stored in total price adjusted, and that will be it. So let's display the new data set, the new data frame, which should have now total price adjusted. So if I scroll to the right, I should see total price adjusted. All right, if you're an Afterwork member, pause the video and work on the challenge. So far we have gone through the 2 packages. Now third package, Tidyr. Tidyr package allows us to perform data cleaning techniques, various data cleaning techniques. So we can decide maybe to separate columns within a data set. So for example, if in this data set we have the following columns, the following data, say for salesperson, we might want to separate it by first name and last name. So how we do that is we can decide to use the separate function from Tidyr. This comes from Tidyr. Specify the data that we want to split, which is the data frame there. Then we want to, inside that data frame, we want to split the salesperson, and we want to split it into this particular 2 columns. And this is a vector. The value here is a vector. And we use a space to define what we want to use in the original column to use as a separator. And then once we are done, we store the outcome of that side, right hand side, inside sales data, and then we display that. All right, pause the video and then work on the challenge. Awesome. Moving on, still using Tidyr, we can unite columns. So by the way, you can perform so many tasks using Tidyr. These are just a few because of course the learning experience can be extensive, but we can plan for that in a future course, which we will, by the way, so subscribe. So uniting columns, so we can decide to combine columns. So for example, we can decide to first of all read the data set here, and assuming that we want to combine to have a new product category column that will be the outcome of product and category. So be shoes, footwear, then shirt, apparel, then separated by a comma. So how do we do that? We use the unite function and we specify the new column that we want to create, and then once we have done that, we then specify, sorry for that. So once we've done that, we want to specify the 2 columns that we want to use to combine, and then we use the separator parameter, and we set it to a dash. So this dash will separate the actual values that we have from those 2 columns. So run this. Okay. All right. Sorry. Sales data. Yes. All right. So you can see that product category has that. Pause the video and then work on the challenge. So we can also drop records with missing values. So sometimes we might decide, actually it's important to handle missing values, and one of the ways we can handle those missing values is just using just dropping them if they do not have a significant impact on our analysis. So this is how we can be able to do. We use the drop NA function. So we are going to load this data set, sales data set, and then we are going to apply the drop NA function to that data set, data frame, which will drop all the missing values, and we can display the clean data set. So this data set initially had 75 rows, but now it has 74 rows. Pause the video and then work on the challenge. All right, moving on. I hadn't written ggplot now. ggplot is the 4th package that we're going to learn, and it's a package that allows us to visualize data So we are going to learn how to create just various charts with ggplot. So initially we're going to load this data set, and we are going to learn how to create now just a bar chart. So starting off, ggplot uses layers to create charts. So initially you would have to define the data that you want to work with. So we want to create a bar chart that contains on the x-axis category and on the y-axis sales. And to define that we want to create a bar chart, we use the geom bar function. For ggplot function, we use it to specify the data and also the axis where we want which variable to go and where. So we use geom bar, and also inside it we specify the start parameters value as identity to mean that we want to create a bar chart. Then we use labs function to add labels, so information such as title, the x-axis label, or the just x-axis or y-axis label. And then we specify theme minimal to just say we just want to use a inbuilt theme, which is just a collection of styles, colors that we, or just not colors, but it just also there's font. There's a whole lot about themes. So yeah, so we want to also apply our theme minimal styles to this visualization that we want to create, and then we run this, and we should be able to see our bar chart. Pause the video and then work on the challenge. Moving on, we can also create scatter plots. So if we wanted to determine the or to visualize the relationship between two numerical values, we can use a scatter plot. So this is how we can be able to do. We can specify quantity.sold, which is this one, or we can just simply not use the ticks. So here, actually, it's supposed to be like that. Quantities sold, then revenue, and geom point. And we can still add all this theme, these other bits, but for ease of understanding, we would add all of that. So once we do that, we run that, and we should be able to see our scatter plot. All right. Line plots the same. You can load this data set. We might want to visualize the relationship between two variables using just the lines. So we could decide to have date, which is in a datetime format already, and color. No, date and sales, sorry. And we can use another variable to just show maybe the color of those points. No, or actually not the color of those points, of the line charts themselves. So we have multiple lines, but sometimes you can decide to just have just the region or not just one, but it depends with the data set. We use geom line. So for each type of chart, we can use a different function. Then we set our labels and as well as set the theme minimal. There you have it. These are just similar lines, but again, this is just for ease of learning. Tibos, but pause the video and work on the challenge, by the way. So by default, when we are working with R, we can be able to use the inbuilt data frames provided by R. So data frames can be provided by Tidyverse, which comes in the form of a Tibo. So what we have been loading with read_CSV is a Tibo. As you can see here, it's a Tibo. It's a data structure that allows us to manipulate data efficiently. Alternatively, we can decide to use read.csv. When we use the read.csv, we tend to use the traditional data structure provided by R by default. So we are going to load the data set, the data set, and store it in a data frame, the original data frame provided by R. But then we can convert it into a Tibo using the asTibo function, and then we can now perform those operations using a pipe operator, using dplyr, etc. Right, pause the video and then work on the challenge. Moving on, we can also filter data. So once we have loaded it, we can perform techniques such as filtering. So here we're going to load this data set using read.csv, not read_csv. So that's something worth noting. So once we have done that, we can now convert it into a table and then perform just various operations. Let's move on. The par package allows us to just apply a function to each element. It just helps us to just automate generally or work with let me just say it allows us to be able to perform operations that are repetitive and generally make our work easier when we are mapping or data with data frames, or when we want to perform the same operation on multiple columns or rows. So for example, in our case, in this data set which we are going to load, we might want to maybe calculate the mean of the numerical columns all in all together. So we can use the mapdf function from par package, and we can pass our data set and then specify the function that we want to apply, which will generally calculate the mean for each column. So if I load this, I should be able to get the mean for the numerical columns. This should also be different, by the way. Yeah, pause the video and then work on the challenge if you're an Afterwork member. String R package, the 7th package. So sometimes we might want to, work with strings. So decide maybe to split maybe strings. It could be first name, last name. Still almost what we did with dplyr, but now with the string R package, you have a whole lot of other tasks. So initially, you could decide to do so many things, by the way. So, okay, in this case, I'm actually using a previous tidyr package. I won't, okay, could actually this separate should be, not sure. I think string R should be string R, because tidyr allows us, I'm just looking at whether the separate package has that function. So we can see the functions that we have for strings. So I think tidyr is the one that has separate. So because in my case, I'm just trying to look at where's tidyr to confirm something. Go to docs and we see separate. Let's say the separate. Yes, it's separate. Should be separate. Yeah. So I think this example here doesn't make sense, but yeah, but some example 2 makes sense because we are using string.title to convert the case of characters in this particular column into a title case. So if I load this data set, I have this particular salesperson one. So if I reload it again and preview it, so I am applying this. I'm also using dplyr and Tbows behind the scenes. So salesperson has John Doe, string to title. Maybe if I could use something else, not just string to title, maybe to str to lower. I could try to lower or to upper. Let me see if I can be able to do that. Str to upper. So just 1p. To note that change. So if you are to look at that, you can see salesperson now has uppercase. Here it has title case. So here you can change it to uppercase. All right, pause the video and work on the challenge. You can also try str to lower, and which is provided by by this str package, string R package. Forecasts is the other package that we can use, and this is useful for working with categorical variables. So for example, we might want to rename the categories within our categorical variables. So let's say, for example, in our case here, we have this category. We might want to rename this category variable, the values, maybe specific ones. Let's say furniture, we want to rename it to furnitures, lighting to lightings, decor to decors. So then we can use muted functions provided by dplyr. We can also use the fct recode function provided by forecasts to be able to make that change in that categorical column. And voila, we should be good to go. furnitures, we have decors, etc. Lastly, we can also use LubriDate package from Tidyverse to be able to perform various techniques. So for example, we can convert a character to date. So if we had this data set and this column date, we can be able to convert it to a date time format using YMD, and we replace the values of the date column, and we display the data which we have here. Pause the video and then work on the challenge. We can also extract date components. So assuming that we want to maybe prepare data or create new data for further analysis, we might decide to, so for example, if I run this code, we can be able to see that we have the following information, but we also have specific date. Maybe we have order.date, which, where is it? Let me see. Okay, we have this order.date, which is here. Actually, it's order space date, but we can still work with it. So you need to just change these to what you're seeing here. Sorry for that. I should have overseen that a bit earlier. I should have seen and made some changes earlier. So you need to put the delimiters because the column names don't have full stops. You'll get errors. That's what I'm doing. So what I am doing is in this code. So once I have this, I'll remove the periods. So what I'm doing here is I'm converting order date into a date time format using the YMD date, and then I'm storing that in the order date, original order date column. So that I'm doing that for these. I'm actually, wait a minute. This is not okay. All right. I think this is a different data set. So I'm extracting. Sorry, I think I had it wrong there. So I am extracting the dates. Here I am converting order date into order dates into date time format, then storing the outcome here. Then I'm getting what I'm getting here, and I am storing, I am using it to extract the year. So I'm extracting the year from order date and storing it in order year, and which is a new column. Then I'm also extracting the month and I'm storing it in order month, and also the day, and storing it there. So if I run this, I should have new columns, which are these ones that you see at the very end: order year, order month, and order day. Pause the video and then work on the challenge. I can also calculate date intervals with LubriDate. I can also decide to create a new column that has a difference of the dates. So for example, in my case, if I run this code, I should be able to see that I have the following dates: order dates, then delivery, etc. information. So I can also be able to perform that change. The only issue here is that I have to perform the technique as mentioned, but now I also would need to modify my code to specify that I'm selecting from order date column. So I could have done that a bit earlier, but you can still use the mutate function, or you can apply, you can still apply the change using this structure that we have used here, where we are converting the order date, ship date, and delivery dates columns into date time format, and then we're storing them here, and then we do a difference. And once we have done a difference, we create a new columns, and then we display them. I won't run this. This will give me an error. I should have fixed that a bit earlier. But you can actually use an earlier. Can you use an earlier data set? Just try and look at which. No, you can't use an earlier data set. Just work with what you have, but now change the order date to have now the delimiters on this enclosed on the side. So yeah, so that's it generally with regards to this learning experience. I hope you were able to have achieved a few things in terms of getting to understand what Tidyverse entails. If you're interested in learning a bit more about Tidyverse, you can consider going to our YouTube channel and scrolling through a bit more, and you'll find some some R fundamentals courses. It could be also visualization or data cleaning or data wrangling. And yeah, so we hope you have been able to get some value from this learning experience. And if you did, please give this video a thumbs up. It tells us that we should keep on continuing providing more of such learning experiences. And if you'd want to be informed when we post such future workshops or videos or courses, which we hope to do that specifically for different packages in the future, be sure to subscribe to this channel so that you can get notified quickly and be ahead of the pack and be ahead of everyone in terms of being able to implement or to create solutions that change the world. All the best in your learning journey, and see you in the next video. See you next.